Free body diagram is a very important tool for force analysis in engineering mechanics. I strongly encourage you to always construct a free body diagram as the very first step of force analysis. A good free body diagram can significantly improve your problem-solving efficiency, and on the other hand, a poor or no free body diagram can often result in confusion, longer problem-solving time, or failure to solve the problem. So, what is a free body diagram? Why is it free? It is a sketch of a system that is isolated from its surroundings, therefore free of contact or constraint. Note that here I use the word system instead of a body or an object. This is because your study object can be a particle, a rigid body, or even a system of multiple bodies. After you isolate your study object from its surroundings, sketch it, then you need to demonstrate the magnitudes and directions of all the external forces acting on it to the best of your knowledge. Let's use this example. Step 1. We need to be clear what is it that we are interested in analyzing, what problem to solve for. In this case, we'd like to analyze the forces acting on the dog. Step 2. We need to isolate the object from its surroundings and sketch it. It is crucially important that you are clear what the chosen system is and make sure to only include that system. In this example, see how we don't include the string, the toy in the background, or the floor, just a puppy. And of course, it is not necessary for us to be so detailed about the sketch. After all, we only want to do a force analysis. So we can simplify our drawing to a block that represents a rigid body, or even a dot to represent a particle, depending on your goal. Then we need to demonstrate all the external forces acting on the object. In this case, the external forces include the dog's weight, which is the gravitational force exerted by the earth to the dog, normal force, which is the support force exerted by the floor to the dog, applied force, directly exerted by the string to the dog, but indirectly exerted by probably a person. And lastly, the frictional force, again exerted by the floor to the dog. Sometimes you might not know the magnitude or direction of certain force. That is okay, just fill in the information to the best of your knowledge. Note that for a rigid body diagram, when you demonstrate the location of the application point of the force, it is important to be as accurate as you can. For a further simplified particle free body diagram, all forces simply act on the particle, which, as you recall, is simply represented by a point with mass in space. As a summary, when you sketch a free body diagram, make sure to include the object of interest, all the external forces, and an appropriate coordinate system. You shouldn't include any other objects, forces exerted to other objects, for example, the force exerted by the dog to the floor, and also you shouldn't include internal forces. I cannot stress enough how important for you to be clear on the system that you choose for your analysis. Your system could be a single body or multiple bodies. Note that the multiple bodies in the system don't necessarily have physical contacts. Depending on how you define your system, the free body diagrams should be sketched differently. For example, if you only choose the train engine to be your system, then on the free body diagram, you should include the weight, the normal supporting forces, the frictional force, and the force between the engine and the train car. However, if you choose the entire train as your system, then you not only need to add the forces acting on the new parts, which are the new weights and the new normal forces, but more importantly, you need to now exclude the force T, since now force T is considered as an internal force within the system, therefore should not appear on the free body diagram.